So now they're asking for us to write an equation with a parabola. If it has a vertex at 0, 0, directrix at x equals 2. So here's 0, 0. Here's my directrix at x equals 2. So which means my focus has to be over here at negative 2. So the distance here between the vertex and the focus is going to have to be a negative 2 distance. So anything that's positive here, I already know that those aren't going to be the right answers for me. This parabola, because its directrix is vertical and its focus is on the x-axis like this, it's going to have to be on its side. Remember that our normal template here is y equals 1 over 4p x squared. When we turn the normal parabola like this on its side, we're going to end up switching the x and the y's. So this is going to say x equals 1 over 4p y squared. Again, we know that it has to be a negative number. The only one that's really written in the correct format here, where it's x is equal to and then y squared, is c. If we wanted to make double sure, we take this negative 2 and we substitute it in for p. 4 times negative 2 is negative 8, so x equals negative 1 over 8 y squared. And that's what we see here. Number 15 asks us to use the graph of this function to find the solutions of the equation. We look right here and we can see that there are two solutions that are coordinate pointed in for us. We have one solution where x is negative 1, and we have another solution where x is 3. Negative 1 and positive 3. So 15 will be h. If they wanted you to write this in factor form, you would say x plus 1 times x minus 3 equals 0. If you multiplied these two factors together, you would get your original equation. So these are all just various states of solving. You take your equation, you factor it, you turn it into solutions. Or you take your solutions, you put them into factors, you can multiply those factors using the array to get the original equation, forwards and backwards. Number 16 asks us to find the solutions here of the equation. So what I will do is add 2 to both sides, and I get that x squared plus 12x plus 4 is 0. I'm seeing a lot of square roots here, so what I'm thinking is going to happen is that I will use the quadratic formula since it has a square root in it, and that will hopefully help out. So I have a, b, and c, and we're going to use negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. When we substitute in, I get negative 12 plus or minus the square root of 12 squared minus 4 times 1 times 4, all divided by 2 times 1. This is negative 12 plus and minus 144 minus 16. So when we look at our calculator, 144 minus 16 will give us 128. We divide that by 2. 128 can factor for us into 16 times 8. This is all under the radical again, so the square root of 16 is 4. So we know that we're going to have a 4 outside of the radical. 8 can factor for us into the square root of 4 times 2. The square root of 4 is 2, so I know that I'm going to have a 2 out of the radical. And I'm left with just the square root of 2 underneath the radical. And this makes sense for me because all of my answer options have a square root of 2 here. So my answer so far is negative 12 plus or minus 8 square roots of 2 divided by 2. And all of these numbers are thankfully even, so I can simply cancel out or reduce my terms. So negative 12 divided by 2 is negative 6. 8 divided by 2 is 4. So my final answer should be 6 plus or minus 4 squared to 2. So 16, the answer is C. The next one is asking me for which equation has the roots. They're giving me something really important here. By letting me know that there's an imaginary, this means that I can just look for the discriminant for most of these to see if the discriminant is negative. The discriminant, remember, is this piece of the quadratic formula, just the square root section. It's going to tell you if it's negative, then you're going to have imaginary roots. If it's positive, then you're going to have 2 real roots. And if you're discriminant, if what's under the radical is 0, you're just going to have 1 real root. So let's take this new knowledge and apply it to this. The discriminant is just going to be the square root of b squared minus 4 times a times c. Almost immediately, I can tell this is going to be positive 36 and negative 100. So for sure, this discriminant is negative. 17 very well could be f, because we know that a negative discriminant will give us imaginary roots, like we see here. So f may be our answer. Let's go on to some of these other ones. We have the square root of b squared minus 4 times a times c. And it kind of looks like we're going to run into the same problem here. We have 36 minus 100. Again, this will be negative. In the next one, b squared minus 4 times a times c. And we can see here that 4 divided by 4 will go away. So this is 9 minus 25. This will also be negative. And then b squared. Negative times a negative is a positive. So this is positive 25 and then a positive 9. This discriminant is positive, which means we'll have 2 real solutions here. So h isn't going to work. Look at this. We have b squared minus 4 times a times c. I have 9 minus 4 times 25 over 4. This is 9 minus 25, which is also negative. All right, let's look at the rest of the formula now that we were able to toss out h. Your formula starts with negative b, and then we divide it by 2a. All right, so the opposite of negative 6 is positive 6, and then we would divide it by 2a divided by 2. 6 divided by 2 is 3. So my answer needs to be 3 and then an imaginary number. That's looking pretty good. Let's go to the next one. My opposite of b, there we go. My opposite of b is negative 6 divided by 2a. Again, we're right here in the formula. Negative b divided by 2a plus or minus the discriminant. We already did. So negative 6 divided by 3 times 1 by 2a is going to give me a negative 3. My answer has a positive 3. So G is not the right choice. For part J, we're going to use, again, negative b. So that's going to give me a positive 3 divided by 2a. 3 over 2 does not appear in our answer. So F has to be the right one. Which is the value of x in the right triangle will be our last question on this page. The value of the right triangle when it is x. Remember that your equation will be a squared plus b squared plus c squared. A squared plus B squared equals C squared. My A is just x. My B is x minus 14. And it needs to equal C squared. I could solve this out, and that's what they want me to do. So I would use the array method here. Say x minus 14, and then x minus 14. This will give me x squared minus 14x minus 14x. And then equals plus 196. So this will be x squared plus x squared minus 28x plus 196 equals 34 squared. 34 squared is just 1156, so we have 2x squared minus 28x plus 196 equals 1156. We can keep solving out for x. And on number 18, if we substituted in 30 here, 2 times 30 squared minus 28 times 30 plus 196. And if we've done it right, when you substitute in your answer options, 16, 26, 20, into the equation that you made, 30 was the one that came out to be 1,156, and that's what we needed to balance the equation. So x must be equal to 30.